Hello, I'm Michelle Stonecastle, and this is my demo on creating a highly available environment with Amazon Web Services. In this demo, we'll be going over the purpose of high available environments, inspecting deployed environment, creating an application load balancer, creating an auto scaling group, going over updating security groups, and then looking at the flow of data over the network. Purpose of a high availability environment. We'll go over a little bit more detail in the next slide, but first I wanted to show a part of a larger architecture. So you have this large architecture with a region. It's got a VPC in the region, and the VPC has a public subnet, it has two public subnets, and it has two private subnets. And then in the middle, you have the application load balancer, which is connected to the Amazon EC2's auto scaling instance. And that's going to help distribute everything across it. So we need to understand what elasticity and scaling is. With elasticity, resources can be required when needed and released when they are not needed. Elasticity enables you to increase the number of web servers when traffic to your application spikes, and then lower the write capacity on your databases when traffic goes down. It can handle the day-to-day fluctuations of demand throughout your architecture. Scaling is a technique that is used to achieve elasticity by increasing or decreasing the compute capacity of your application. There are two types of scaling. You have horizontal and vertical scaling. Horizontal scaling is where resources are added or removed. So there's scaling out, which means added, and scaling in, which means removed. Vertical scaling is where you increase or decrease the specifications of an individual resource. Example is EC2 can be stopped and resized and then restarted. Scaling is the ability to increase or decrease the compute capacity of your application. So with a need, why we need the elastic, highly available instance is because modern applications must be able to handle massive amounts of data with no downtime and with sub-second response times. A reactive system can be implemented that is elastic, resilient, responsive, and message-driven. For example, with instances in AWS, autoscaling enables dynamic adjusting of the number of EC2 instances in response to traffic fluctuations, ensuring constant performance during peak periods while minimizing the cost during lulls. Features like AWS availability zones and AWS elastic load balancing help distribute traffic across instances and availability zones, minimizing the impact of failures. AWS CloudWatch provides comprehensive monitoring and logging capabilities, allowing tracking metrics, setting alarms, and gaining insight into the cloud resources, health, and performance. A well-designed reactive architecture can save a lot of money, and it provides a better experience for all the users. Here's a short demonstration of inspecting a deployed environment already. Here we're going to look at the VPCs. Go to your VPCs and you see Lab VPC. It's got a details page. Here we have the subnets, and there's a private subnet as well as public subnets, and there you can see that they're in two different availability zones. Here's the route table. And then the network ACLs. Going on to the security groups. The The security groups have inbound rules and outbound rules, as shown. Here's the outbound rule. There we go. Here is a little video demonstrating how to create an application load balancer. To build a highly available application, it is a best practice to launch resources in multiple availability zones. Availability zones are physical separate data centers or groups of data centers in the same region. If you run your application across multiple availability zones, you can provide greater availability if a data center experiences a failure. Because the application runs on multiple application servers, you will need a way to distribute the traffic amongst those servers. You can accomplish this goal by using a load balancer. This load balancer will also perform health checks on instances and only send requests to the healthy instances. Here we're building the security groups. We've got our subnets selected. We're going to actually have to create a new security group. Going over the basic details, giving it a name, a description. We're creating the inbound rule for HTTPS for anywhere IPv4. So, security group is successfully created. Now we're going to go back over to the load balancing. You have to refresh the drop-down menu in order to get the just created security group or target group, whatever it happens throughout all of AWS console. You need to remember to refresh. So, and then we're also removing the default one, picking our security group. Next, we have to specify group details. We want instances. Let's see, actually. This is creating a target group. You have to make sure that we've selected the lab VPC. And then in the advanced health check settings, this is where we're adding a healthy threshold of 2 and an interval of 10 seconds. Healthy threshold of 2 seconds. And then create our target group. Once we get back to the load balancer, we'll have to refresh the drop-down menu. And then we can select ours. And there we go, we've created the load balancer. Amazon EC2 Autoscaling is a service designed to launch or terminate Amazon EC2 instances automatically based on user-defined policies, schedules, and health checks. It also automatically distributes instances across multiple availability zones to make applications highly available. In this task, we will be This is showing how to create an auto-scaling group that deploys EC2 instances across the private subnets, which is best practice for application deployment. Instances in a private subnet cannot be accessed from the internet. Instead, users send requests to the load balancer, which forwards the request to the EC2 instance in the private subnets. So creating an Amazon machine image is one of the steps. Create it from the existing web server. This will save the contents of the root volume for the web server so that new instances can be launched with an identical configuration guest operating system. Then create a launch template. A launch template is a template that an auto-scaling group uses to launch EC2 instances. When you create a launch template, you can specify information for instances such as the AMI, the instance type, the key pair, and the security group. Once you've completed those steps, you will need to update your security groups. The application that was deployed is a 3-tiered architecture, and you can see that in the diagram example here. We've got the load balancer security group, application security group, and then the database security group. Now the security groups configured to enforce these tiers. Configure the load balancer security group. It accepts all incoming HTTP, and HTTPS traffic. The load balancer has been configured to forward incoming requests to a target group. When autoscaling launches, new instances will automatically add those instances to the target group. The application security group was provided as part of the deployed environment already, but now it needs to be configured to only accept incoming traffic from the load balancer. So you have to go back and edit your security groups. The security group is currently empty. The security group that was created and deployed with it is currently empty. So you have to add a rule to accept incoming HTTP traffic from the load balancer. Configuring HTTPS traffic is next because the load balancer was configured to forward HTTPS requests via HTTP. This practice offloads security to the load balancer, reducing the amount of work that is required by the individual application servers. Here we see a little diagram going with a flow over the data network. So the request to the load balancer, which resides in the public subnets that are connected to the internet. The load balancer choose one of the EZ2 instances that reside in the private subnets and forward the request to it. The EZ2 instance then returns the web page content to the load balancer, which returns it to your web browser. My citations and sources. Thank you. This concludes my demo. Thank you very much. Are there any questions?